Physics can sound complicated, but it's really just the rules of how our universe works. Everything around us, from the smallest atom to the largest star, follows the laws of physics. The best part is, you don't need a fancy lab to see these laws in action. Simple experiments can be done right at home. These experiments are fun. They also help us understand the world better. Have you ever wondered why things fall to the ground, or how light bends? Let's explore some mind-blowing physics experiments. These experiments use simple things you can find around your house. Get ready to be amazed. Have you ever noticed how a straw in a glass of water looks broken? That's because of light refraction. Light travels at different speeds through different materials. When light passes from air to water, it changes direction. This bending of light is called refraction. Materials you'll need: a clear glass, water, a pencil, or a straw. Let's get started. Fill the glass halfway with water. Hold the pencil or straw upright in the glass of water. Look at the pencil or straw from the side. What's happening? The pencil or straw appears to bend at the water line. This is because the light rays traveling from the pencil through the water to your eyes are refracted. Think about it. Refraction has many applications in our daily lives. Eyeglasses, telescopes, and microscopes all use lenses that refract light to help us see better. Sound is all around us. From the bustling noise of a city to the serene sounds of nature, we are constantly surrounded by a symphony of vibrations. But have you ever thought about how sound is made? It's a fascinating process that starts with something as simple as a vibration. Sound is produced by vibrations. When an object vibrates, it sets the particles around it into motion. When something vibrates, it causes the air around it to vibrate too. These vibrations are what we perceive as sound. These vibrations travel through the air as sound waves. Just like ripples in a pond, sound waves move outward from the source. Let's do an experiment to see how vibrations create sound. It's simple and fun, and you can try it at home. Materials you'll need: a drinking straw, scissors. These everyday items will help us explore the science of sound. Let's get started. Flatten one end of the straw by pinching it. This will help create the vibrations needed to produce sound. Cut the corners off the flattened end to make a point. This pointed end will act like a reed in a musical instrument. Put the pointed end of the straw in your mouth and blow across the edge. You'll start to hear a sound as the straw vibrates. What's happening? When you blow across the straw, your breath causes the sides of the straw to vibrate. These vibrations are what create the sound. These vibrations produce sound waves. The sound waves travel through the air and reach our ears, allowing us to hear the sound. By changing the length of the straw, you can change the pitch of the sound. A shorter straw produces a higher pitch, while a longer straw produces a lower pitch. Think about it. Musical instruments like flutes, trumpets, and even our own vocal cords produce sound through vibrations. The next time you hear music or someone speaking, remember that it's all thanks to the amazing phenomenon of vibrations. Have you ever rubbed a balloon on your hair and watched it stick to a wall? That's static electricity. Static electricity is the buildup of electrical charges on the surface of an object. Materials you'll need: 2 inflated balloons, a piece of wool fabric, or your hair. Let's get started. Rub one of the balloons vigorously against the wool fabric or your hair for about a minute. Hold the rubbed balloon near the other balloon. Now try to stick the rubbed balloon to a wall. What's happening? Rubbing the balloon creates static electricity. The rubbed balloon becomes negatively charged, while the wall is neutral or positively charged. Opposite charges attract, so the balloon sticks to the wall. Think about it. Static electricity is used in many applications, such as photocopiers and air purifiers. Lightning is also a dramatic example of static electricity in action. Section 5, the physics of flight, paper airplanes and aerodynamics. Humans have always dreamed of flying. From the myth of Icarus to the sketches of Leonardo da Vinci, the idea of taking to the skies has fascinated us for centuries. But how do airplanes stay up in the air? What keeps these massive machines from falling back to the ground? It's all about aerodynamics, the study of how air and objects move through the air. This science helps us understand the forces that act on an airplane. Let's build a simple paper airplane and explore the forces of flight. This hands-on activity will give us a glimpse into the principles that allow real airplanes to soar. Materials you'll need: a sheet of paper. Let's get started. 1. Fold the paper in half lengthwise and then unfold it. This creates a center line that will guide your next folds. 2. Fold the top two corners down to the center line. This forms the nose of your airplane, which will help it cut through the air. 3. Fold the top edges of the wings down again to meet at the center line. These folds will shape the wings, which are crucial for generating lift. 4. Fold the wings down one more time, making sure the creases are sharp. Sharp creases help maintain the airplane's shape during flight. 5. Throw your airplane gently. A gentle throw ensures that the forces of flight can act on the airplane effectively. What's happening? 4 main forces act on an airplane: lift, weight, thrust, and drag. These forces must be balanced for stable flight. The wings of your paper airplane generate lift, while the weight of the paper pulls it down. Lift must overcome weight for the airplane to stay aloft. Your throw provides the thrust, and air resistance creates drag. Thrust must overcome drag for the airplane to move forward. Think about it. By understanding aerodynamics, engineers design airplanes, helicopters, and rockets that can soar through the sky. This knowledge allows us to explore new frontiers and push the boundaries of what is possible in aviation and space travel. Section 6. Exploring gravity. Building a simple pendulum. In this section, we will delve into the fascinating world of gravity by constructing a simple yet effective pendulum. This hands-on experiment will help us understand the fundamental principles of gravity and motion. Gravity is the force that pulls everything towards the center of the Earth. It's a universal force that affects all objects with mass, from the smallest particles to the largest celestial bodies. It's what makes things fall to the ground and keeps us on the planet. Without gravity, we would float away into space, and life as we know it would be impossible. Let's build a simple pendulum to see gravity in action. Materials you'll need: a string or yarn. The length of the string will determine the period of the pendulum, which is the time it takes to complete one full swing. A small weight, like a washer or a bolt. The weight will act as the pendulum bob, and its mass will influence the pendulum's motion. A chair or a doorknob. These will serve as the fixed point from which the pendulum will swing. Let's get started. 1. Tie one end of the string to the weight. Make sure the knot is secure so the weight doesn't come loose during the experiment. 2. Tie the other end of the string to the chair or doorknob. Make sure the string can swing freely. The point of attachment should be stable and not move when the pendulum swings. 3. Pull the weight to the side and let it go. Observe how the pendulum moves. What's happening? The weight will swing back and forth. This motion is called oscillation, and it continues until friction and air resistance slow it down. This is because of gravity pulling the weight downwards. When you release the weight, gravity accelerates it towards the lowest point of its path. The pendulum's motion is a constant battle between gravity and inertia. The tendency of an object to resist changes in motion. Inertia keeps the pendulum moving past the lowest point, while gravity pulls it back down. Pendulums have been used in clocks and other timekeeping devices for centuries. Their regular motion makes them perfect for keeping accurate time. By understanding the principles of a simple pendulum, we gain insight into the forces that govern our world. Section 7. Surface tension. Surface tension is a fascinating phenomenon that allows liquids to behave in unexpected ways. It's the force that holds the surface of liquids together, making them act like a stretched elastic film. Materials you'll need: a bowl of water, pepper dish soap. Let's get started. 1. Sprinkle a small amount of pepper onto the surface of the water. 2. Dip your finger into the dish soap. 3. Touch the surface of the water in the center of the pepper with your soapy finger. What's happening? The pepper will rapidly move away from your finger towards the edges of the bowl. This is because soap reduces the surface tension of water. The higher surface tension of the surrounding water pulls the pepper outwards. Think about it. Surface tension plays a crucial role in nature. Insects like water striders can walk on water due to surface tension. Section 8. Center of gravity. The center of gravity is an imaginary point where an object's weight is evenly distributed. It's the point where you could balance an object perfectly. Materials you'll need: a ruler, a pencil. Let's get started. 1. Balance the ruler on your finger. 2. Mark the point where the ruler balances. This is the center of gravity. What's happening? The ruler balances at its center of gravity because the weight is evenly distributed on both sides of this point. Think about it. Understanding the center of gravity helps us in everyday life. It's why we lean forward when carrying a heavy backpack and why tightrope walkers use long poles for balance. Section 9. The importance of hands-on learning. These physics experiments are not just about magic tricks. They're about understanding the fundamental laws that govern our universe. When we try these experiments ourselves, we learn by doing. We see the principles of physics in action, and that makes learning more exciting and memorable. So go ahead and try these experiments at home. Share your discoveries with your friends. Remember, the world of physics is full of wonders waiting to be explored.